can start joining in. Good evening, Ed. Good evening, Ram. Good evening, Nikki.
Good evening.
We have 30 participants and the number is steadily increasing. I think with due respect to the participants who have joined in time, I think it will be right if we just go ahead and start the program. So, good evening, ladies and gentlemen from the United States of America. Good morning to my friends in India. Greetings to you all from Explore the Space. Explore the Space, an NGO promoting space education across geographies in association with Elcon Precision LLC, a metal finishing company based in San Jose, USA, is pleased to present you this international webinar series on future of space technology and exploration. I will start a very brief presentation of mine, and then we will request the chief guest and other speakers to give their very valuable inputs for this very interesting program. Nikki, I'm going to share my screen now. Nikki, are you able to see the screen?
Yes, we can see it.
So you're able to see the first screen?
Yeah, looks good.
Thank you. Thanks for that. Thank you. Friends, Explore the Space is an NGO promoting space education across geographies in association with Elcon Precision LLC, a metal finishing company based in San Jose and a direct supplier to NASA. Now, this particular edition, we're going to speak on human exploration of outer space, past, present, and future. This webinar duration will be for 90 minutes. The objective of this series is to encourage the global youth to pursue STEM education and space technology, facilitate industry-institution linkages in space and allied industries, and to emphasize on global space cooperation. After 3 successful editions in June, September, and November 2021, today we have the 4th edition of the webinar series, and this edition will be on human exploration of outer space, past, present, and future. We welcome for today's webinar the chief guest, Mr. Joseph Abraham, the Consul for Economic Affairs, Israel Consulate General, Bengaluru. Most welcome to you, Mr. Joseph Abraham.
Thank you.
We most welcome to you, sir. We
Thank
welcome Mr. Ed Tomasek, Director, Business Development, Elcon Precision LLC, the American company with whom Explore the Space is partnering in doing this series of webinars. Welcome to you, Ed. We also welcome, we are especially delighted to welcome Mr. Ram Prasad Gandhiraman, the keynote speaker for today, who is the founder and CEO of Space Foundry, company in San Jose, USA. Now, ladies and gentlemen, the first edition of the webinar in June 2021 was on advanced materials for launch vehicles, which was addressed by Mr. Tim Dyer. We all know that space vehicles are expected to travel enormous distances over long periods of time without an opportunity for maintenance, refueling, or repair. And such space vehicles are subjected to temperature spikes, gravity variations, radiation, pressure, impacts, and vibrations. Mr. Tim Dyer's presentation helped in the understanding of the importance of the manufacturing process for material and components to be used in outer space industry and the amount of diligence and patience that the process demands. Friends, the second edition of the webinar in September 2021 was on NASA's Artemis mission and humanity's return to moon. It had Dr. Jaideep Mukherjee, Director, NASA FSGC, as the main speaker. The Artemis program is a United States-led international human spaceflight program, and its primary goal is to return humans to the moon, specifically the lunar south pole, by 2025. Dr. Jaideep spoke about the space exploration, NASA's Artemis program, and the problems and challenges of lunar explorers. The third edition was a very interesting one where we had a lot of interaction with the student community. It was in November 2021, and it was on microsatellites, manufacturing, and operational challenges. It had Mr. Tim Dyer along with Nikki and Rebecca. Now, after 3 highly successful and interesting webinars, we now move to the third edition, Human Exploration of Outer Space, Past, Present, and Future. Ladies and gentlemen, there are a plethora of opportunities in the space and allied industries, and it is only growing. Ground systems offer great opportunities for building space stations and support systems and subsystems. Some of the opportunities for the student community include additive manufacturing, artificial intelligence, big data, cybersecurity, drones, hypersonic, information and communications technology, machine learning, optics, quantum computing, robotics, space law, and the list goes on. Now, this emerging scenario demands that we all work together to build an inspiring workforce for the space industry for the future. Now, how can this be done? Well, we are exactly trying to do that. We support STEM and space-related initiatives in educational institutions. We develop programs to enable students and young professionals to gain real-world space-related educational and professional experiences, attract international space experts into the space education and industrial sectors. Ladies and gentlemen, we are also pleased to share with you that we promote Space Tech Expo, the largest and most attractive space industry show happening in the United States of America. This happens once in the US in May, and then in November it happens in Germany. Now, this is taking a real good shape. Now, with these initial remarks, ladies and gentlemen, I take pleasure in introducing our chief guest for the day. Most welcome to you, Mr. Joseph Abraham. Now, a few words about Mr. Joseph Abraham. Mr. Joseph Abraham arrived in India in 2021 to serve as the Consul for Trade and Economic Affairs of Israel at the Consulate General of Israel in Bangalore, India's high-tech capital. As part of this position, Mr. Joseph is responsible for promoting Israeli exports, attracting foreign investments, and strengthening economic ties between Israel and the southern states of India. Earlier to this, Mr. Joseph has served as the economic attaché in South Africa, Boston, USA, Houston, USA, and Istanbul, Turkey. Mr. Joseph was in charge of investment promotion from 2007 to 2011 at the Investment Promotion Center in the Ministry of Economy and Industry, and also served as a representative of the Ministry of Economy and Industry in Israel. Between 2015 and 2021, Mr. Joseph Abraham served at the Directorate of Industries at the Ministry of Economy and Industry. Mr. Joseph holds a bachelor's degree in mechanical engineering from Ben Gurion University and an executive MBA from the University of Haifa. Ladies and gentlemen, we take special pleasure in welcoming Mr. Joseph Abraham to this program. Over to you, Mr. Joseph, for your inspiring inaugural speech. Mr. Joseph, please.
Thank you very much. I hope I'll be able to tie to the other people that are going to be speaking about space, but I'll try. Ladies and gentlemen, shalom. It is a pleasure and honor to inaugurate the 4th edition of the webinar series on future of space technology and exploration organized by Explore the Space, an international organization working on space education, and Elcon Precision LLC, an American company that does business with NASA. Allow me to extend congratulations to Mr. Venkatagiri, CEO, Explore the Space, and his team for inviting me to inaugurate the seminar. I would also like to note Mr. Ed Tomasek, Director Business Development, Elcon Precision LLC, San Jose, CA, USA, and Mr. Ramprasad Gandhiranaman, the keynote speakers who will be going to speak on human exploration and outer space, past, present, and future. We all eagerly look forward to hearing their presentations. As mentioned, my name is Joseph Abraham, and although I served as an Israeli career diplomat, I am a mechanical engineer. I think the closest I got to space or space studies was doing a 4th course in rocketry during my undergraduate studies at the Ben Gurion University, or visiting NASA in Houston. That being so, this talk will give you on this webinar will give you an insight into the Israel Space Agency. The agency is responsible for initiating, leading, and coordinating all activities of the civilian space program. This agency supports scientific research and development with real economic potential, and I mention that because, as you all know, I am responsible for trade and development and economic affairs between India, the southern states of India, and with Israel. Because of the economic potential, such as the development of unique and innovative technologies. In addition, the agency operates on the premise that all space-related activities contribute to the Israeli economy, to the country's international standing, and also benefits its citizens in terms of agriculture, communications, monitoring of economic pollution, and research. The goals are diverse. They include expanding cooperation and reciprocal relations with the various countries in the field of space. They include the development and construction of satellites, and I'll give you a little example at the end of this. Investing in startups. The agent also cultivates, and I think this is extremely important, a cadre of future scientists through space education and community projects. The goal is to strengthen the connection of children and youth in the field of space in order to satisfy their greatest natural curiosity in this area and to expand their knowledge and interest in space. For the general public, the agency also organizes activities and events that offer interactive experience in space-related subjects. And throughout the year, they organize a range of activities, stargazing, astronomical activities, natural competitions, technology, initiatives in schools, trainings, courses, and instructors, and more. As regards Israel's space industry, Israel has a long-standing successful space heritage, including technological development, applications, competitive products for the space industry. It was established in 1980s, at a time when Israel was the 8th country in the world to succeed in launching and positioning satellites in space. Gentlemen, and ladies, I hope everybody knows that Israel is a country of 9 million people. I think it's smaller in population-wise than the city of Bangalore or Bengaluru. So having said that, and I think the state of Karnataka, allow me to mention, is nearly, I think, 10 times larger than the state of Israel. So we're a very small country, but being 8th in number is not a bad position, if you will allow me to say. Among Israel's satellites in space, I think everybody knows the Amos, a series of communication satellites, Eros, photography satellites, TechStart, research satellites, and of course, Bereshit, Bereshit, as everybody knows, is the term for Genesis. It's the first book of the Bible. And Bereshit, as you all know, was the challenge that everybody was wanting to go into. Apart from that, Israel has been forced to deal with security challenges and a shortage of resources. And consequently, it has focused in miniaturizing technology and developing small light satellites, high resolution, remote sensing, and communications. Israel is considered a world leader in this industry, a small country with a relatively technology advantage in the field. Israel's space industry is engaged in the development, production, and operation of satellites. We specialize in development of technologies for miniature satellites and methods of launching them. Based on this technology and expertise, a number of Israeli groups are currently developing microsatellites, nanosatellites. They also focus on high-resolution photographic satellites. We have a relatively modest budget, as everybody knows. We're a small country, but the achievements of the space program have been impressive of Israel's advanced technology industry's achievements. We have low-weight imaging satellites and are considered the leaders in the global arena. We have space cooperation, and I think we were talking about this a few minutes ago, with NASA, ESA, which the UN, these are all acronyms, which is very difficult, but with France, Germany, Italy, Canada, and last but not least, with ISRO, which is India. I had the privilege of being there a day or two ago. Notable projects include vegetation and environmental monitoring by microsatellites, or researching environmental preservation and precise agriculture, which is an important topic in India, I'm quite sure, which was successfully launched in August 2017. There's also Shalom, which is actually observation satellite for scientific and commercial use. There's also ultraviolet transient astronomy satellites for exploration of shock waves, effects after gravitational waves, supernovas, black hole mergers. A launch is expected in 2024. As I was mentioning, Bereshit 2 is in the planning stages. I would also like to mention a project to build nanosatellites, which will be designed by high school students. I think, again, the emphasis is on children, on youth, and getting them into space. I wish the organizers of this program Explore the Space and Elcon Precision LLC all success as they do the series of webinars to promote space education among the youth of the world. I thank you all for giving me this opportunity to talk to you on space. It has brought me back a little bit more to my other passion of mechanical engineering. I hope I will stay with it a little bit more. And I wish you all and all those listening all the success in whatever they do, and especially in space. Thank you, ladies and gentlemen, and shalom again.
Thank you. Thank you very much, Mr. Joseph Abraham, for that very inspiring inaugural address. Israel is a great source of inspiration. That it's a country that many people like me admire. Ladies and gentlemen, we take pleasure in welcoming Mr. Tim Dyer. Mr. Tim Dyer is the president of Elcon Precision, who is the moving spirit behind this series of webinars. Welcome to you, Tim. Ladies and gentlemen, after the inaugural by Mr. Joseph Abraham, I have pleasure in welcoming Mr. Ed Tomasek, Director, Business Development of Elcon Precision LLC. A few words about Ed. Ed Tomasek has a BS in Biology and an MBA from University of California, Irvine. He started at Elcon Precision in 2016 as Director of Sales and Business Development, and is responsible for bringing in new business to Elcon for both the etching and assembly sides of the company. Before coming to Elcon, Ed spent a combined 20 years in the ceramics industry at Kyocera, Carpenter Advanced Ceramics, and Morgan Advanced Materials, primarily in sales, business development, and product manager roles. He began his career as a researcher in the medical device industry, working on the development of a hollow fiber, artificial kidney, and anti-calcification treatments for implantable heart valves. His undergraduate studies focused on marine biology, and early in his career, Ed has also taught island ecology and marine biology on weekends at the Catalina Island Marine Institute. Over to you, Ed, and most welcome again, Ed Tomasek.
PDV. I'm going to give a short overview of what Elcon Precision does. We're a small company located in Silicon Valley, San Jose, California. We've got a couple divisions in the company, and I'll give you a quick overview of the kinds of things that we do, what kind of company we are, and then more specifically, some of the projects that we've worked on that are actually in space. You see a few of these here on the head slide, but I'll go into more detail as we go on. So we're a small company founded in 1967, 51 employees, about 34,000 square foot facility. We're AS 9100 certified, which is the aerospace certification, ISO as well as RoHS and ITAR. We've got four main markets: biomedical, defense and aerospace, electronics and commercial, and renewable energy. What I'm going to talk about mostly today is defense and aerospace, and touch a little bit on renewable energy and how it relates to doing things on the moon or maybe Mars with electrolyzing water to turn it into oxygen and hydrogen. So we have two business units: our metal products division and ceramics products and assemblies. The metal products division is mostly photochemical engineering. Sorry, photochemical etching. We take thin sheets of metal and we process it in a way to give a burr-free, stress-free parts. We remove the metal using photolithography patterns and then create 2D and 3D components. You might also hear it called chemical milling, photo etching, or photochemical machining. We do a lot of different materials. Our specialty is refractory metals. There's not a lot of people in the world that do that. So molybdenum, tungsten, titanium, hafnium. We do a lot of pure metals: copper, nickel, palladium, alloys, some specialty metals. And we also do what's called selective plating. It's really just the opposite of etching. So we're adding metal to it via plating. And we can combine that with photolithography, so we can print patterns on and add metal via plating around or to different features on the parts that we're making. Here's a really simplified diagram of the etching process. So we choose a material. Typically, a customer is going to choose the material. Usually, these thin sheets are anywhere from 1,000ths to maybe 20, 30 thousandths thick of an inch thick. We laminate both sides of it with a resist coating, which is light sensitive. We use a digital patterning tool to image the patterns on both sides of it. And then we etch the metal, and the metal is etched where the pattern, around the pattern that we put on there. So anywhere we put a pattern, the metal is not etched, and vice versa. And then we remove that resist and then remove the part. So in this case, this light right here in step 3 has drawn this little antenna part. And when it's done being etched, you can see how it's been etched around and created the part. And then you get this little end product here. So it's a great way to make thousands, hundreds of thousands of parts at low cost, no burrs, doesn't affect the metal, and it just makes really nice parts. Wide range of things that we do. These little triangular things are antennas. These are lids for packaging. These are either grids used for traveling wave tubes. These are more little things called carriers. We can form things into little boxes like this for RF screening. And I think the next page shows a few more things. This is a medical product. This is a medical product. This is used to make artificial joints. This is used to detect brain waves in your brain. So these little things pop out of that sheet, and they have little very sharp tips on them that attach to your scalp, and then they can read brain waves coming out of your brain. This thing on the right, this is an example of what we do in the hydrolysis business. So this is an actual product. It's just a demonstration of all the different kinds of channels that we can make. So this is actually a very thick piece. It's about 100 thousandths thick, and the metal that's etched away in all these channels is etched about halfway through the part. So now I'll go into a few things that we've actually made that are in space. So for the NASA Solar Explorer Sunspot Imaging Program, we made this grating. So this is made out of tungsten, which is a very hard material to etch and to work with. It's a lot easier to etch than it is to machine. So we're able to make all these fine little features in this grate. And we made multiple instances of this that are quite accurate part to part, and then they're stacked up together to create this much thicker piece. And these gratings are just used to look at sunspots, and you get different diffraction patterns as you look through them. So it's used to image solar flares and characterize chemical properties of the sun. Another technology is electrolyzers. These are used to create hydrogen and oxygen out of water. So you're basically cracking water. And we see this as a potential use on the moon and maybe other planets. You can create oxygen and hydrogen, which is a fuel, from water, and it's found in the form of ice at the bottom of craters in the moon's south pole. So if we can bring these sorts of things up to the moon, now we've got a source of oxygen and fuel that otherwise, if you were to bring it up in a spaceship, would be just enormous costs. You couldn't colonize the moon without something like this. So we make these etched titanium anodes for electrolyzing the water to form hydrogen and oxygen. This PEM membrane is probably the leading technology right now for electrolysis. And here's some examples here and here of what these look like in assemblies. And down here are these are just some examples of different kinds of electrolyzers. So the other division we have at Elcon is our ceramics product division. This is a division that metallizes ceramics and sapphire. And we also do a lot of brazing of the metal to ceramic, and also plating and glazing. The benefit of painting ceramics with metallizing paints is that you get a uniform coating with a uniform thickness and density. It bonds strongly to the ceramic, and when you create hermetic assemblies with it, you get high hermeticity, so almost pure vacuum tight, and there's very little oxidation. There's a couple little examples down below here, but I'll talk about some more specific ones later. So the process is to create a thick film refractory metal paint. So this is a moly manganese paint typically, and we paint this onto ceramic and then fire it onto the ceramic, and it gives you a reliable means to do brazing to ceramics. If you try to just use a brazed alloy on bare ceramic, nothing would stick because the brazed alloy has nothing to grab onto on the ceramic side. So this metallic ceramic forms a base for the attachment of metal via brazing with an alloy filler. And then when you've got this assembly, it's electrically insulated, and hermetic, and it's good for feed-throughs and other features. The most common ceramics we process are alumina, sapphire, beryllium oxide, aluminum nitride, zirconia, and zirconia toughened alumina. Work with a lot of metals. We try to get the best match for thermal expansion to the ceramic part. So the most common ones are Kovar, copper, moly. We do some stainless steels and titanium and others. And the alloy fillers, typically copper, silver, gold, germanium, and some active metal braze alloys. So in terms of space, our paints enable metal to ceramic assemblies that are able to withstand the high temperatures and voltages prevalent in lunar and spaceflight applications. Here's some examples of some brazed assemblies. We make some very tiny things. This is an X-ray source. It's actually sitting on a US penny, so it really is that small. And here's some examples of mostly feed-throughs and other brazed assemblies. We also do metal-to-metal brazing, and we also make this vacuum relay switch that's actually used in some cases for launch interrupt. When NASA launches a rocket off the coast here, if something goes wrong and they have to knock the rocket down if it's off course or something, obviously not with humans on board, but if they're launching satellites and something goes haywire and is heading towards land, these switches are used in the radar system to abort the launch and hopefully send it into the sea. It's a very complicated part. This is what it looks like in the side view. I won't go into the details, but it's a very complicated and actually quite expensive part. Here's a little bit smaller part. This is more like the size of your thumbnail, and this is used for an X-ray tube. So specifically for space, we are on the DART mission spacecraft heading to Didymos. We made 2 electron guns on the Next-C ion engine, which I'll show you a picture of. It was launched in late 2021, last November. It's going to take about 10 minutes or 10 months for the spacecraft to get to Didymos, which is this larger of the 2 asteroids here. It's going to crash at very high speed into this smaller moon, and it's going to very slightly but measurably change the orbit of this. So it's actually called space defense. So the hope is that if an asteroid ever gets loose and heads towards Earth, we can send one of these satellites up, crash into it, and change its orbit just enough to alter its trajectory to Earth and save humanity, so we don't go the way of the dinosaurs. So this is what this xenon engine looks like in the spacecraft. So this is the back end of the DART spacecraft, and this is the engine in the middle here. So we make this neutralizing electron gun, and we also make this electron gun here. So it uses xenon gas, which are all these green bubbles here. It ionizes it and then accelerates the ions through this grid, and xenon's got a fairly high mass. So as it does that, it's able to accelerate the spacecraft. So it allows you to put a spacecraft up there without a lot of solid or liquid fuel, just gas, and use this propulsion system to send it something like 6,000 kilometers an hour, I think, when it finally crashes into the asteroid. We also participate in other ways in the space industry. For SpaceX, we have components on Starlink satellites that are up there now. There's a couple thousand up there now. As I described, we made ion engine components for the DART program, and we did some grid plates for one of the 10 instruments on the solar orbiter. We also work with Space Foundry, which is Ram's company. He'll be talking after me. We provided some incubator space and infrastructure for them to develop our products. They make a plasma jet 3D printing that can be used in space. And this 3D printing is going to be necessary. It's going to be an important manufacturing technology on the moon. We also have partnerships with academia, University of Michigan, Chicago, UC Davis. Tim Dyer, our president, he's a member of the UC Davis Materials Engineering Advisory Board. We work with SLAC at Stanford University, and we've also worked with Cal Poly San Luis Obispo on some facilities redesign. So, we encourage students to come to us. We've sponsored a couple of student teams for senior projects, and we welcome any other teams that have good ideas for us to work with us, usually over the summer. So that's the end of my presentation. I think the main point for me is to say that even though we're a small company, we participate quite a bit in the space industry. So we want to encourage students out there in any of the STEM programs to look at small businesses as well as large businesses if they're interested in space. I'm going to show you a short video here. We also do a Space Expo. We have a booth at the Space Expo. It's held in Long Beach. We were there last, I think, November. We're going to be there again this coming April or May, I think. And just want to show you a short video of what the show is like. And if any of you are stateside, encourage you to go visit. So bear with me a second as I load the video. And then right after that, DV will introduce Ram as the next speaker.
Events like this are really wonderful. It's really hard to replicate the serendipitous nature of bumping into people and the chance encounters, and that's really been my experience thus far. I've met some great people.
It's great to get back to a live conference again, meet with colleagues and chat, see some of the exhibit booths. Very, very fascinating work going on right now. This conference is really unique in terms of having both breadth and depth of knowledge.
The Space Expo experience this year has been pretty incredible for me. I just came off a panel, and it was an all-women panel. So how's that for diversity? It's really interesting and encouraging today to see collaboration happening across civil, across government, across the industry, and see new industry participants coming to bear from the startup world.
Thank you, Ed. Thank you for this. Thank you very much for this presentation, Ed. Your mention
I'll hand it
about
back to you, DV.
yeah. Thank you, Ed. Your mention about electrolyzer technology, NASA's DAP mission, and the electron gun are a great education for us. Thank you very much for that, ladies and gentlemen. Mr. Joseph Abraham, the chief guest, has to leave on an urgent assignment. Can I request a few remarks from you, Mr. Joseph? Your presence has been a great inspiration for us. Over to you, Mr. Joseph, please.
I'd love to. Mr. Ed Tomasak, you mentioned a small company. Let me assure you that small companies and small countries usually make the biggest impact in everything that we do. So it has been a pleasure to hear from you. You have given
Thank
an
you.
exciting and fascinating presentation. You are at the cutting
Thank
edge
you.
of technology. I'm sure about that. And I'm sure that your impact is going to give a boost. And I'm not at the moment making a pun on that word boost to the many people that are just now listening to you. On a little personal note, I'm going to add, I have two very close family members. One who is working in space suits, in the development of space suits, and the other one who's a student learning aerospace and space engineering. So on that slight note, allow me to be a little bit modest, but you guys are definitely at the cutting edge of technology. And I thank you for giving me the opportunity of not only presenting, but also of listening to the fascinating aspects of your technology. Thank you, gentlemen and ladies, and I wish you all the best in whatever you guys do. Thank you.
Thank you. Thank you very much, Mr. Joseph. Thank you.
Thank you, Joseph.
We'll be sending you the recorded version of the presentation, and you'll have the opportunity to view the entire program.
Appreciate that.
Thank you, Mr. Joseph. Thank you.
Thank
so
you.
much. Ladies and gentlemen, I take pleasure in welcoming the keynote speaker of the day, Dr. Ram Prasad Gandhiraman. Dr. Ram Prasad Gandhiraman is from Coimbatore. Coimbatore is a place that is very close to us. Coimbatore is in news for many reasons. I'm sure Dr. Ram Prasad is keenly watching that. Dr. Ram Prasad Gandhiraman is the CEO and co-founder of Space Foundry Inc. Dr. Ram Prasad is a materials scientist with over 15 years of multidisciplinary research experience in plasma processing and material science. He is the CEO and co-founder of Space Foundry Inc. He worked as a staff scientist at Universities Space Research Association, USRA, and contract research scientist at NASA Ames Research Center, California. Dr. Ram Prasad's research focuses on diverse areas of material science and engineering, including development of advanced nanomaterials and sensors, printing technology, sensors fabrication, and biointerfaces. Interestingly, Dr. Ram Prasad received his BSc in Applied Sciences in 2000 from Coimbatore Institute of Technology. Now, this information, ladies and gentlemen, particularly to students in India, is a great deal of encouragement. While studying engineering is always very good, one often tends to think that studying science may not lead to positions like this. So here we have Dr. Ram Prasad, who is a towering example, who did his BSc in Applied Sciences, then went on to do his MSc in Material Science from PSG College of Technology and PhD from Dublin City University, Ireland. Dr. Ram Prasad worked as a postdoctoral researcher in Biomedical Diagnostic Institute, Dublin City University, before moving to NASA ARC in April 2012 and founding Space Foundry in 2016. Over to you, Dr. Ram Prasad.
Thank you very much, Dr. Venkatgiri. And thanks everyone here. So I'm gonna, before I begin, I'd like to thank both Tim and Ed for inviting me over here. And as Ed mentioned, we are located at Elcon Precision. So they have been hosting us, providing us, they've made some investment in Space Foundry. And, we have been very privileged to be part of this Elcon family. And I'm just gonna share, okay. Yeah, so you can see my screen, right? And so, yeah, before getting into the topic, so I'm a co-founder and CEO of Space Foundry. We are a NASA Ames spin-off. The technology was originally developed at NASA Ames Research Center here in California. And I used to be working on site as a contractor, and then with my collaborator from Dennis from Stanford, we started this company, licensed my own patents, and NASA had actually invested in us heavily. So our business focus is printed electronics product manufacturing. We are currently selling equipments and are also working with some large corporates for printed service model. And NASA has invested in us through several programs, primarily on small business innovation research, phase 1, 2, 2E, 3. We have an active contract for the with NASA for the past 4 years. So this already Devi had mentioned. So my bachelor's and master's both from Coimbatore, applied science, material science, and unfortunately I didn't have get a chance to do the engineering, which is usually in India we do engineering and then think what else to do. So I ended up doing material science and then went to do a PhD and postdoc in Ireland. Meanwhile, I also spent about an year in Finland, closer to Russia. And then I moved to NASA Ames in 2012, worked there for about 5 years, and then started this company. Interestingly, I'm also an industrial collaborator and also advisor to a newly formed research center at IIT Madras that is focusing on extraterrestrial manufacturing. So I'll discuss about the human exploration of outer space. I'll primarily focus this on the efforts that has been taken so far, primarily by private companies, right? So for us, for human exploration, there are several things that are absolutely needed. The primary thing is food. We need really good spacecrafts, infrastructure to sustain life, and beyond that, if you have food, spacecraft, infrastructure, you will still need a purpose, because not all the governments have a lot of funding to keep sending people on fun trip to Moon, Mars, and continue to do build the infrastructure, while every government has some serious commitment to look after its own people. So there is a deep purpose here, in all these human space exploration that directly and indirectly benefits the society. There's definitely some long-term benefits. I'll discuss about that. So regarding the food aspect for any human space exploration, so far it has been like a trip to International Space Station, not that long. Then trip to Moon is going to take 3 days. So that's not a big deal. You can pack food for 3 days, come back without any issue. Any journey beyond Moon, Mars is going to take like at least 18 months return. There's absolutely no way you can survive with food taken from here and then have everything there. So the primary focus is on synthetic biology enabled applications for long duration space missions. Like I won't dwell too much on the food topic here. So and then looking at the lunar missions, probably most of you have attended the previous talks on Artemis mission. So the initial phase 1 on the lunar mission is to send a crew to lunar surface by 2024, and then build the capabilities and use that as a launch site to go to Mars. So if you look at the NASA roadmap, the way it has been looking at is like, like there is a LEO, low Earth orbit, and then you get to the Moon, and then to further cislunar space, and then later on to the Mars. So far, all our effort has been to International Space Station, which is about just 150 or 200 kilometers up from Earth, whereas Moon is about 3 lakh kilometers from Earth. So it's a really long journey to go to Moon, even from International Space Station. So the idea here is develop some capabilities in International Space Station and then transition over to lunar surface, and then later on use that to travel to Mars. See, the main issue is uh, nobody knows how materials properties behaves as we go into microgravity. If you're, say, for example, 3D printing something or growing some crystals, the properties that are of these materials that are manufactured in Earth is totally different from that that are manufactured in space, mainly because there is no gravitational pull. And so there are companies that are really trying to use that to our advantage. So there is like a lot of work that needs to be done in the what you call as LEO, low Earth orbit, where International Space Station is, before we can transition to Moon and then to Mars. So for this decade, International Space Station is going to be heavily dependent upon to do a lot of research for carrying forward. Of course, the lunar thing is also going to happen. So one of the primary thing here is that, when it comes to, as I said, there's a purpose. There needs to be a purpose where the governments that are really spending money needs to come up with justifications on why money is being spent on space programs when there are so much needs, right? We all know that everybody needs a cell phone. We all need TV. We really need good bandwidth internet. All this, whether you are rich or poor, everybody wants all these things, right? But the essential resources that are needed, for example, rare earth metals that are really needed for these touch screens, or really good fiber optics that is needed for you to get a really good bandwidth internet, you really need all these materials. And we in the earth are living with finite amount of resources. And there's like a lot of geopolitics around controlling these materials and minerals, especially over the past 10 years. There has been some significant geopolitics that has happened around minerals, metals, rare earths, and who owns what, like how do we control the supply chain, how do we use that to our advantage. So, fortunately or unfortunately, these resources are spread across the earth. Only certain countries do have access, certain countries have capability to extract, and the rest of the people are dependent on them. There is a possibility that we can, change this, and by looking at the space, basically, start looking at moon and asteroids and see what are the things that are available there, and that can really make our lives better, right? I'll discuss about that as well, how it's going to really impact. Some of the things that has really happened over the last 5 years, especially here in US, is how do we really make use of manufacturing in space, or how do you really use of the resources that is available out there in the space and make it for, bring it back to Earth. The simple thing that they could think of is, hey, there is a solar energy, right? Everybody wants green energy. We have now, solar panels. But what effort has been going on now is to actually huge amount of effort that has gone into what you call as on-orbit servicing and assembly, where they're trying to get the convert the solar energy into RF up in space and then beam it to Earth. right? So when you're doing that, you're basically, making use of the best solar power that you can get, and then use that and power it. You can actually power the entire city or the country if you have enough solar panels up in space. So that means like you have absolutely green, a form of energy that you can get, and that's out there. And if you look at these pictures here, the bottom left, you will see what is called as DARPA. I'm not sure many of you are familiar. This is basically Defense, Advanced Research Program, basically funded by Department of Defense. So far in the last, until few years ago, space has been exclusive, focus of NASA. All these defense organizations would just, focus around all the missiles and intercontinental ballistic missiles or whatever. They don't go beyond that. But in the recent past, defense has actually extremely got involved in on-orbit manufacturing. And there is a reason behind that, because these organizations, NASA, these are primarily research-driven, work towards space exploration. But here, the equation changes because you want to use that space, the resources that is available in space, and bring it to Earth. So DoD has actually gotten involved into it. And another thing is that, like, you all know that Earth has a really good magnetic field around it. So anything that comes from solar, flare is protected actually, from reaching us, mainly because of the magnetic field that's there in the Earth. Whereas a moon doesn't have that kind of magnetic field. So as a result, all the solar flares that is reaching the moon gets bombarded on the surface, right? And basically these solar flares are nothing but, hydrogen and helium coming out of the sun. And since there's no magnetic field, this helium just gets bombarded on the surface. This helium-3 in particular is actually in abundance in moon, and it's very rare in Earth. So you can basically use this helium-3 to create a nuclear fission and get absolute clean form of energy, right? So I know, like, this being in Kudankulam, like all these people from Tamil Nadu are very familiar with all the protests and things like that about the nuclear reactor. It happens everywhere. The main difference between nuclear fusion and nuclear fission is that nuclear fusion happens, by splitting up, right? Heavy atoms like, uranium type of materials that are extremely heavy. Whereas, and actually that results in radioactive byproducts that will stay for really large period of time, right? Of course, you can argue whether it's safe or unsafe, that we're getting into political topics there. But, primarily nuclear fission is, radioactive, splitting of heavy atoms resulting in some radioactive waste. Whereas fusion is basically you are fusing these hydrogen atoms and helium atoms to form a nuclear fusion. And as a result, you get the same amount of energy that you would get in a nuclear fission, or in fact, actually much more. This nuclear fusion, you don't get actually radioactive byproducts. So nuclear fusion gives a lot more energy, and at the same time, there is no nuclear radioactive byproducts. So this is like the best, again, the second, best form of energy you can get. Unfortunately, helium-3 is very less abundant in Earth. As I said, we have a magnetic field that protects us from solar flares. So there's like a lot of effort now going on about extracting helium-3 from lunar surface. And this extraction process is, again, not that complicated. I don't want to go deep into that, but helium, like if you look at the periodic table, it's one of the lightest element right next to hydrogen. So extracting helium when you have a mixture of heavy, this is fairly simple, right? And there's companies that are working that have secured. It's a Helion, it's a company here in US. It's the first private nuclear fusion company that has demonstrated nuclear fusion. And of course, they don't use lunar helium, but there is a potential. Once this nuclear fusion is reactors are established, you can get helium-3 from lunar surface and continue, right? And there are also mining precious metals. I have a slide on that. I'll come to that. So basically, you can make use of these kind of resources that is out there, and we can try to keep the planet clean. So this one is on the asteroid mining. There are some companies that are actually looking into mining asteroids, because both lunar and surface and asteroids have a huge amount of rare earth elements and like platinum, gold, and also lanthanum series. So all these metals that are extremely valuable are available in plenty in these surfaces. So without we having to go into war and controlling all these geopolitics, there is potential that we can make use of these resources that is available up there and bring it back to Earth. But of course, what we need is the technology, right? So one of the things that kind of you can look into this. I don't want to get into political, but this happened. This is the reality. That about 10 years ago, China controls about 90% of rare earth metal supply, the global supply chain. Rare earth metals are extremely important for a range of applications, whether you want your cell phone, you want touch screen, or you want a really good speaker or TV screens, your turbines, so without rare earth, there is basically, you don't get any sophisticated device, right? So we are getting into a situation where these metals and minerals are getting into heavily being used for political purpose, and if we let it happen in future, we might end up having God knows what, basically our lifestyle will depend on countries that are really good in materials processing, right? Again, in same with Tamil Nadu, the copper shortage, the copper with Sterlite thing, India became a net importer of copper. So there's like all these things that happens. If we can make best use of these mineral mining and then use the resources that is out there in space, we can basically shift the polluting industries to moon, right? There's like again, these are not dreams. There are things that are happening. I'll show you what's going on. Basically, with International Space Station retiring by 2030, US government has decided to involve private companies heavily, right? And this is the man that basically changed the whole game. Simply by using a reusable rocket, SpaceX basically brought the launch cost to ISS. So currently, over the past several years, the crew transport and cargo transport to International Space Station is done by Elon Musk SpaceX. The launch cost used to be about over $50,000 per kilogram. and he has brought it to $3,000 per kilogram, and he aims to go down to less than $100 per kilogram. So in terms of Indian rupees, roughly, talking about for sending things to space, to International Space Station, 1 kilogram, roughly costs about 40 lakhs, no matter whether you are sending gold or whether you are sending water or whether you are sending food, right? It doesn't matter. Any payload, per kilogram of it costs about 40 lakhs to take it to International Space Station. And he has brought it to less than 2 lakhs. And he aims to go to about 7,000, 8,000 rupees per kilogram. So, this is like a huge like a booster for all those people thinking about, hey, can we do the asteroid? Can we do the moon? The only thing that actually stopped people from thinking about space is this launch cost, which scared everybody, right? Except government, nobody could think of doing anything useful in space. Just because of this, now whole thing changed, right? So with SpaceX, human space flight program, like, you gotta, those who are not familiar, please do visit SpaceX website, try to understand how the Falcon 9 thing changed the entire, rocket industry. And he's working on the Dragon crew capsule. And then the Starship is the one that goes to basically takes people to moon. So here is a multi-story apartment, basically type of thing that he is building to send to lunar surface. There's like a lot of effort going on. The space system launch and efforts are being undertaken heavily, and he is on right track now. SpaceX is on right track to make the lunar infrastructure possible. And obviously NASA and SpaceX, they can only deal with so many things, right? There are really so many problems that needs to be addressed, and that is being addressed by a lot of venture capitalist backed companies here spread in US. I wish I can say that in Silicon Valley, but that's no longer the case, these days. Of course, things happen in Silicon Valley, but it's being spread. So there are now a few companies, Varda Space, funded by Khosla Ventures. They are looking into making space factories, right? So the thing that I mentioned about having all the pollution causing industries shifted to space. So these people are looking into that. And Axiom Space is another company, and that is actually building international space. Basically, they are building a private space station. So all these three companies are building private space stations, right? They all have received contracts from NASA. And the way it is happening is that you have this International Space Station, multiple modules that can be attached. So each of these companies will be developing their own module. It will be launched with the help of SpaceX. It will go and attach to the International Space Station, and they will build the infrastructure. And after a few years, they will get separated from International Space Station and be independent. So they will send their own crew. So by the time 2030, the International Space Station retires, you will have multiple private space stations operating that with different business agendas, right? And then Blue Origin, basically Orbital Reef, is being built by Amazon Jeff Bezos' company, Blue Origin. So, so there are multiple companies that are working with NASA to make this transition happen from International Space Station to private space station. So again, coming back to my very first slide on purpose, what is the purpose? How is it going to help the society, or is it only rich people's game, right? If you look at all these companies, like Jeff Bezos has enough money, he can just build this for fun, right? But actually, that's not the case. So there is actually a lot of value that is being added that will actually make our lives better, like change our lives seriously. So at International Space Station currently, there's a company called TechShot, which got acquired. It's a company called Redwire that is 3D printing organs in space. So when you think about gravity and without gravity, so anything that you print in gravity, the Earth kind of falls on the Earth. Whereas if you do something in space, it doesn't fall, right? So you can use that to your advantage. So if you're printing cells, they're gonna just stay intact, and you can print organs without having some support structures, which will be very difficult to remove if you print in Earth. So efforts are being undertaken to print organs like lungs and heart tissues. And there's also a company working on retinal implants. In space is a company that has done a lot of experiments in International Space Station on the retinal implant. So there is a possibility that you will have a manufacturing space in space low Earth orbit, where organs will be manufactured in space and be brought back to Earth. And there's another example is fiber optics. I'm not sure if you are familiar. Basically, these high-speed internet cables that runs under the sea, connecting the Pacific and the Atlantic. The Atlantic and the Europe part, that runs underneath the ocean. All those fiber optics, you get extremely high quality fiber optics when it is manufactured in space. Remember I said about crystal growth, in microgravity, you get actually high purity, very high purity crystals that are grown in space. So obviously material sciences is one of the boring topics, especially the crystal growth is such a difficult topic to understand. But these things do change our life, right? So they make a huge impact. And then there are discussions on semiconductor industry as well. So Varda Space is one of these 3 companies that are making earthbound factories. So they are looking at re-entry problem, addressing some challenges. And then Orbital Reef is building its own space station with a manufacturing facility. They are also looking heavily into food produce in space. You have Axiom Space basically is now building a space station. Obviously all these companies that are spending millions and millions of money, they also need some sort of revenue, right? So you have really a vision, but at the same time, you got to be very realistic and be able to generate revenue to achieve the vision. So Axiom Space is basically building a studio now, and basically within the next 2 years, they will have a studio, and Tom Cruise basically, is acting on a movie that will be shot in space station, International Space Station, and the module will be developed by Axiom Space. So all these things, you see, like it really, so now LEO, low Earth orbit, acts like an extended home, right? And then we'll transition into lunar surface and then later on to Mars. So Now, a lot of effort is being done, about the low Earth orbit, the International Space Station. So the International Space Station currently is Earth reliant. Everything that you need, we need to take it from here, right? At the same time, there's work now being undertaken for lunar, which is basically going to be a proving ground. What are the things that you can develop there? Can you, set up an infrastructure? So within the next few years, a lot of you're going to see a lot of news on lunar activity. So there's some very heavy investment gone from the U.S. government. At least I know. I don't know about the rest of the governments about setting up lunar infrastructure. I do understand. I think that I don't know that Russia and China have signed up an agreement, and they are also accelerating setting up a lunar infrastructure. And then obviously everybody is looking into using that as a launch pad for going to Mars, and at the same time see what are the resources that can be used and be brought back to Earth, right? And there's like a lot of good treaties that are already in place between these international community. It's not like 14th century, 16th century, where you can any country that goes to a new territory sets a flag and draws the boundary. So that's not the case here. So any country that goes to lunar surface, they cannot own any region, but any material that you can extract, you can bring it to your country. So as of now, that is the agreement that all the countries have signed up for. So you don't have to think about this colonization in a historic context, where when you say colonizing moon, it's like colonizing, the 16th century, 17th century colonization. So you don't have to worry about this. So it's basically you're trying to go and extract resources and see how you can bring it back and set up facilities there. So this is a company made in space, which got acquired. It's a part of a company called Redwire now. So they have been developing this additive manufacturing facility. They've been printing a range of devices, but they don't have electronic printing capability. So this is one example. Like you need real different sensors. You need some electronic components in space. So there is like a lot of effort now is going on about what you call as on-demand manufacturing of electronics. Space Foundry is funded by NASA for that primary reason. I have a few slides, I'll show that. So basically, if you look at International Space Station, it's a closed environment, right? Basically, there is no tap. People take water in sip. It's in a small container. Even when they brush, they just swallow the paste. The life is very difficult in International Space Station because you are living with very limited resources. Even the urine is being recycled. They do say that recycling system is made here at NASA Ames Research Center, the same building where I used to work, one floor above my lab. So they're the ones who made this filtration system, and according to them, that's the best form of water you can ever drink. It removes all the impurities and salts and crystals, everything. So you're basically working in a small environment, and you got to print a range of devices. So there's a lot of effort now being made to print like energy generation system, like solar panels in space, because these solar panels are large, right? So launching becomes very difficult. So there is a lot of effort now on manufacturing these solar panels in space. You can create a really large kilometer long solar panel and leave it up there. So and there are storage devices, communication antenna. So all these are being now looked at. The major issue is zero gravity. So there is limited energy supply. You can't have toxic materials. There's no waste allowed. So this manufacturing in space has its own issues. It's not like, hey, whatever equipment you have, send it to International Space Station and manufacture. So in space, basically the reality is very different. So it's very challenging. There is difficulty in ventilation. There is limited air filtration. Basically there's no flammable, you can't take highly flammable materials. There are no biohazards. So you can't have toxic byproducts. So a lot of issues around manufacturing in space, and it's all being addressed. There are a lot of companies that are addressing. There's like a lot of government funding going on, in these areas. So basically, I'd like to have few slides on just show how Space Foundry fits in this whole scheme of things. We are really tiny, small company. So we are, what we are doing is we're trying to enable this in-space manufacturing. And so there are different components that are involved in this manufacturing of solar panels, and communication devices. You need antennas, you need certain metals, interconnects. So all these that are part of this needs to be printed, right? So when you are printing, there are a lot of issues around. You need really good quality inks. For example, when I'm saying printed electronics, you're printing, say, copper or silver ink, and then you're curing it. Getting to fundamentals, basically, when you're curing, basically you're baking this material. The electronic structure changes. Copper becomes copper oxide, silver becomes silver oxide. The conductivity, the performance decreases. So what Space Foundry has done is we have developed a novel technique called plasma jet printing. Basically, it allows printing. There's no curing step involved. As I remember, we can't have real lot of supply chain issue, in space. So limited resources, limited space. So we got to be cautious about all these things. So we have developed a process, a hardware, and a solution for printing a range of electronic materials. And we've printed a range of materials. Currently, we're focusing on copper and silver. I can skip this. So some of the things, it's a communication antenna that we printed. For different application needs, we've been printing a range of materials. And then 2 months ago, we actually took our printer in what is called as a parabolic flight, that takes us to a zero gravity, where we could actually print. So I have a small video. We printed antenna, some electrodes as well. And so I'm gonna play this video. So so we had, like, when you see the text below. So we had 4 days to demonstrate our product and show that we can print in zero gravity, and our printer works. So in first day, there was some major communication failure. We could not print. And then in second day, there was another failure, so we could not print. And on third day, it worked. And then fourth, it still had some issues. And then fourth day, it worked perfectly fine. So this is basically what you see in the text below is different days where there are certain issues, and then finally we succeed. Each flight costs about $50,000. It's about 35 lakhs for each day. So every day we spend 35-40 lakhs, and it was very difficult when you don't, when you fail, right? There's like a lot of pressure on us. And so that's what you will see when towards the end, when it starts printing, we will be really enjoying. So this is also called, you tend to vomit a lot. So that's why you see the guy here, Daniel, he was actually vomiting with the bag, and still, he was working. Then you see the plasma, it's printing.
It's on, right? Oh yeah, I want that too.
So we basically, printed some communication devices in microgravity. That's it, 4 people. So we are a small company. Some differences where you see when you grow in Earth, you see all these globular thing, and then in microgravity, kind of surface tension takes over. So there's like a lot of difference in film properties that you see. These are some of the equipments that we developed and installed. This robotic arm. And then we installed in several customer locations. This is how the entire product was developed over the period of years. 2015, it was just a proof of concept demo, and it has gone a lot of iteration. And we kind of developed, there's like proof of concept, different things. And then one of the idea was to the way the project started was it's called a synthetic biology enabled printed electronics, where there was a group that was working on genetic engineering of microbes. Remember my very first slide where I said synthetic biology is going to enable a lot of space mission applications. There's like a lot of effort going on about food. There's also effort now genetically engineering the microbes to see if they can be used to mine the metals. And then we kind of did some work on killing the microbes. These are sterilizing surfaces we can use plasma to sterilize surfaces. So there's like a wide range of applications for this technology, and also for treating water, for example. So we can use this plasma to treat the water, also treat the air. So we kind of have few press release as well, and it's my email. Feel free to reach out to me. And I think that's about it. Sorry, it's a really long presentation. Feel free to ask any questions.
Thank you. Thank you very much, Ram. That's a very, very impressive and highly educative presentation. Hats off to you. You are making both India and USA proud. We are very happy about you.
Thank you.
Nikki, we saw some questions. Can we request?
Yeah, so since we're running short on time, let's go with 2 questions.
Yeah.
Let's go. There's one from Ivan to Elcon Precision. What are the advantages of photochemical etching compared to ordinary machining? Is it only a matter of component size? And he's mentioned cell components that are of machinable size, but does this have to do with structural properties of the outputs of the 2 processes?
There are actually some parts I showed that look like they could be machined, and they probably could. But the main advantages are mostly in terms of scale. Number one, in terms of the numbers of parts we can make on a sheet, just hundreds of thousands at a time, rather than just making one at a time that you would do with CNC machining. And there's also a limitation on thickness. So on the thin side, we can etch things that you just can't machine. You can't machine a half a thousandth or a 1,000th or 2,000th piece of metal efficiently. On the other hand, you can't really etch anything that's more than about a millimeter thick, depending on the material. So we can actually combine the two, etching and CNC machining, but you know, etching isn't always the right solution for your part, but it is the right solution if you need to make thousands or hundreds of thousands of parts, especially if very thin materials and things like tungsten that are almost impossible to machine efficiently. So we do combine the processes, but it really takes the right application for us to be able to photochemically etch something.
Thanks, Ed. And then we have one more question, and this is to Ram from Sorna. And Sorna is completing their degree in physics and is interested in space-related research. Do you have any advice or guidance, especially since, you've been in the industry?
Yeah, now, with, ISRO also now getting very active with university engagement. As I said, there is in IIT Madras, they started a new research center called focusing on extraterrestrial manufacturing. And it's a multidisciplinary research center. Professor, it's his name, Satyan Subbaya is from mechanical engineering, and then another Ramachandra Rao from physics department. These are the 2 people that are really leading. So, obviously without, unless both science and engineering work together, and also now we have this really cool biology, synthetic biology. So, this space thing is going to be extremely interdisciplinary. My advice would be to reach out to some of these institutes that are focusing on multidisciplinary programs, and be open to learning all the other topics as well, whether it's chemistry or engineering. Yeah.
I should also add too, we go to this Space Expo that's in California. So if you have an opportunity to go there, do that, go around, talk to people. Don't be afraid to ask a lot of questions. Companies like us love curious engineering students and physics students. And even in your own country, wherever you are, there should be some shows or other venues to go, and just don't be afraid to ask a lot of questions because people really want to help.
That was really helpful, Ed, because space industry trade shows are beginning to happen in India also, now that the COVID wave is settling down. And that should be a good opportunity for Surna and others. Uh, yeah, I have a query from the gentleman from Uganda. Yes, we can send you the video on space tech. We'll be happy to do that. Nikki, do we have time for any further questions?
I think we're about nearing the end.
Okay.
And I don't see any other questions
Yes.
on my end.
Sorry, I just saw one question,
Okay.
Satyavrat, about a lot of money being spent on space exploration. It's a very valid question. NASA is being asked the same thing, right? There's cancer that needs to be cured. Why are you worried about moon or asteroid, Mars? Every country has its own problems, and governments have tough time answering the public. Hey, see, look, of course, curing cancer is important, looking after our people is important, and at the same time, these kind of activities also need to be done. If not, if, say, for example, take any country, it doesn't matter whether India or US or China or Europe, it doesn't matter. You don't do, somebody is going to do, right? And they're going to develop the infrastructure, and then you're going to lag behind, right? So you got to make progress on all the fronts, whether it's science and tech or business or healthcare. We can't leave behind one and just focus on another thing. So as governments, they need to focus on multiple things. And as I said, these solar panel projects or the helium-3, these are some of the best, cleanest form of energy that you can get. Imagine, you use helium-3, bring helium-3 from moon and have these nuclear fusion reactors with zero radioactive material that can power the entire cities or the state. What else do you want, right? So these things will come up unless we spend money, the government spend money, explore, we won't know what is out there. And same way now organ printing is coming up. Companies that are very convinced that printing organs in space is going to really make a lot of impact on the healthcare side, because they do see that there's a huge advantage in printing in microgravity in space, especially the biological materials. So there's like a lot of effort in going on. And then obviously you also need high-speed internet. Who doesn't want high-speed internet? You all want to stream movies, watch Amazon, Netflix, right? This fiber optics, you get extremely few form of fiber optic manufactured in space. Then there's no bandwidth issues. You can watch any number of movies in your phone, talk to anybody. So, like all these benefits that we really take it for granted do come from, government's, visionary investments.
Can I break in, DV, real quick?
Yeah, yes, Tim, most welcome.
Yeah, I just say that I appreciate Ram for participating in this event. His work with Elcon has been great, and he's a fantastic person, and Space Foundry is a great company. Dennis is brilliant. So I think that we can expect a lot of great things from them. I also really appreciate your work, DV, Explore This Place, bringing together people. And remember, space is a visionary thing that unites us all. It crosses politics, it crosses religions. It is something where we are visionary, where we want to make technology better. We want to be able to focus on creating something better, a better world. Space is a great way we can collaborate on that, because it divides political lines. And that's what DV has done with this event, is he really created something that is apolitical and just wonderful. Again, I really thank you, DV, and then Ed and Nikki for your participation in this event. So again, thank you all for attending a great event.
Thank you so much, delegates, particularly to Ed and Ram, and special thanks to Nikki for all the support. And a big thanks to Tim for being the moving spirit behind this program. Thanks to all the delegates. Those of you who are interested, just send an email so that we can send you the certificates. Thank you all. Special thanks to Ram and Ed. Thank you again. Bye-bye.
Thank you very much, DV. Yeah, thanks everyone.
DV.
Thank you.
Bye.
Good night.
Thank you, Nikki. Thank you. Bye-bye.
Yeah. Good night, everyone.
Yeah.